Hello, welcome to my channel. Today I will explain how to make a custom footprint using Kicad. Now before to begin, we need to have a datasheet first to show an image diagram. So what I'm gonna do is type out datasheet.com. Now our datasheet.com is a search engine for searching electronic component datasheet. It has transistor, diode, capacitor, almost anything. Now what I'm looking for is this LM324ADTBG. Now once I find this, click PDF. Now this datasheet has information about a conductor, a test, a dimension, characteristic, and so on. Okay, this is what I'm looking for. Now, once I find it, next it's to open Kicad. Click Footprint Editor. Now, click New Footprint. Then enter footprint name. So, I'm gonna just get it. Okay. Then, click OK. Okay. So, what I'm gonna do is to add path first. Right. Now, double click this path. So, what I'm gonna do is to follow the diagram. Now, this diagram showing information about length and width. This length is 1.52 millimeters. Say this, measure millimeters. And the width is 0.58 millimeters. So what I'm gonna do is this. Type 1.52. This one 0.58. Okay. This pattern is SMD. Okay. Once it's done, click OK. Now next is to make a quotient. Now click this, the rectangle. Click. So I'm gonna just edit. Click. Now the height and width is. So I'm gonna follow this table like this. Just bit assume that. Now this A, the millimeter it says the minimum is 8.55, max 8.75. What I'm gonna do is Just follow the max. Okay, fine. The Y, the P is 6.2 millimeters. Okay, line weight doesn't matter. Okay, then click OK. Okay, that's done. Now, something missing is this thing is yellow. So what I'm gonna do is just change the layer. Just F click OK. Okay, the coaster is done. Now back to pen. Now what I'm gonna do is to copy and paste this to make a 14 pen. 14, yes, 14. Now still see the feed. Okay, it's done. Now what I'm gonna do is to change the position of these pads. Because this is not very accurate. So what I'm gonna do is like this. Not very good. Now the pitch is 1.27. So what I'm gonna do is uh, click like uh, position tool. Click this position relative to. Now select item. E is on the bottom. Okay. Oh, oh. Select. Click OK. Now this done. So gotta make sure it's correct. Okay. Now, now I'm gonna fix this. Okay, I think this all done. So next is to change the numbers. So what I'm gonna do is double click. Now type 2, okay, 1, 3, click, wait, sorry, 4, 5, uh, this one, 8, and 10, 12, 13, 14. Okay, this, okay, okay, the path is done. So next is to make a body. Now click this, the rectangle. Okay, next is follow this B. Now the B says 4.00. Uh, what I will do is it is 4 meters. Height is okay. That's 8.5. Click OK. Uh, the layer is F6 screen. Okay. And make sure it's good. Now I'm gonna just okay. This okay. I think this done. Now next is to the circle. There, there's a circle, a dot, right here. So what we're gonna do is this. Okay, okay, click OK. So I'm gonna just put like here. That's it. And like okay. Uh, next to some text. Text said LM32 for DTEG. Okay, done. Okay, now, okay, okay, check in. Okay, that's pretty much it. Now, I will explain information about what is bad, what is good, yeah, so on. So, it's bad, good, bad. Now, I'll explain the code. Now, the code yeah, is in PCB, its footprint refers to the outermost boundary around the component. It defines the minimum area needed for the component, including assembly and soldering, without interfering with adjacent component. The codec is crucial for ensuring mechanical clearance during manufacturing, assembly, and testing. The purpose of this codec is to ensure sufficient spacing between adjacent components, preventing issues during placement, soldering, and rework. Now, the SMD, that's this path, is also means solder mask defined. Is path a type of PCB path where the solder mask opening defines the size of the path. It used to create more compact and efficient circuit design. Next is the F-path, also known as front fabrication layer, is used to define the precise mechanical outline and placement information of components on the front side of the PCB. It is for the fabrication process, as it provides the necessary detail for component placement, but it is not typically printed on the final PCB. Next is F6 screen, also known as front screen layer, is used to define the printed marking that will appear on the top side front of the PCB, typically used for component identification, orientation, and general labeling. Next is left. Now left also known as left band designation layer, which include F left front left band and B left back left band, is used to display the left band designation for component on the PCB. It is for identifying and locating components on the PCB during assembly and troubleshooting. Okay, that's pretty much it. Explain that. So next, what I'm gonna do is to save this footprint. So click File, Save, and it's LM32 for ADTBE. One, two, ah, ah. Okay, I think that's all for making custom PCB. Thank you for watching my video. My name is Raditya Kuncorojati, name 123490024. Rekayasa Instrumentasi dan wait. Rekayasa Instrumentasi dan Automasi. And see you again. Bye.